Welcome back. Let's talk about problems 2 and 3. Problem 2 says use your visualization skills and the models that you have built to fill in the information about 2 other prisms and 2 other pyramids. Hopefully you were able to do that. Number 3, your answers will vary, but this is what I came up with. So for the prisms, if n was the number of sides of the base, so in other words, if it was a triangular base, n would be 3. If it was an octagonal base, n would be 8, and so on. Well, I noticed that the number of faces was always 2 more than n, and that the number of vertices was 2 times n, and that the number of edges was 3 times n. For the pyramids, again, I let n be the number of sides of the base. I found that the number of faces was 1 more than n, and the same thing for the number of vertices. And also for the number of edges, it was 2 times n. Hopefully you are able to see why that works out. Okay, for the patterns for all of the polyhedron, if you look at the number of faces, the number of vertices, the number of edges, I found this pattern. So the number of faces plus the number of vertices was equal to the number of edges plus 2. So it wasn't quite equal to the number of edges. I had to add 2 to the number of edges in order for it to be equal. Well, if I subtract 2 from both sides, I get f plus v minus 2 is equal to e, the number of edges. And that's Euler's formula. Euler was a famous mathematician that lived quite a while ago, and he noticed this pattern between the number of faces, vertices, and edges in any polyhedron, and that's the formula I was trying to get you to figure out. Please take a look at number 4 and watch the last video.